Okay, so we are on page 17.
So would a bursary topics of this unit still be like important like them?
It's still important, but I talked about how on the AP exam, it's mainly can you recognize what that notation is doing, and second, that we understand that derivative is basically slope. We saw that visual connection. That slope formula kind of looks like a limit definition of derivative. That's really the most important thing. But here on out, we're going to be relying on a much more efficient way of getting to our.
Will that be any quizzes?
No, quiz is going to be starting function from here on out. Yeah. Okay, so I want to keep reminding us that anytime we see the word derivative, I just want to have connecting that with something visual, with slope, right? Steepness, right? So, I know derivative sounds so abstract and complicated, but if we just continue thinking about slope, I think that's something that we can visualize, and that's something that's tangible, right? We know what slope is. So here's the first rule: this is the constant rule. Constant rule says if my function is just a constant, then my derivative is 0. I want to kind of prove that to you here. F of x equals 5. What does this graph look like? Or what if I wrote it a different way? Y equals 5. What does that look like?
It's going upwards. Or
horizontal line. Yeah, horizontal line. So y equals 5. 1, 2, 3, 4, 5. So here's my y equals 5 line. So if I ask you, what is the slope of this line? What would you say? 0. So that's why we say f prime of this function is 0. Or I can say, since my y is 5, therefore my y prime is 0. So y prime or f prime is saying, what is the slope of this line? And the slope of that line is 0. So y prime is 0. Now, there's a lot of different notations there. F prime represents derivative. Y prime represents derivative. We also have these notations, dy, dx. Is also another variation of derivative notations. So we're going to see all these different notations. They also represent derivative or slope. Let me give you another example before I go into this power rule here. What if I have an equation y equals 3x minus 21? What is the slope of this line? Because that's the m, right? So therefore, I can say y prime of x is simply equal to 3. Or f prime is equal to 3, right? So the slope of my line is 3, so my derivative is 3, right? Slope derivative. Now we can do this all day as long as we have a nice line, whether it's horizontal or slanted. But as soon as we get into curves, then our derivative requires variables because the slope is ever changing. So we need something that represents that change. It's not just going to be a static value, right? Static number. So here's power rule. This is going to be much more efficient than what we did with a limit definition of derivative. So here's the rule. The rule says if I have a variable raised to an exponent power, then my derivative or my slope formula is just this. I'm going to bring that exponent down and then subtract 1 from the exponent. So bring the exponent down as a coefficient in front of the variable and then subtract 1 from the original exponent value. Okay, let me just do a quick example here. So if I had f of x equals 3x to the 4th, my f prime, or my slope formula, is simply, I'm going to bring that exponent down. When that exponent comes down, it's going to multiply with the what? 3. So it's going to be 4 times 3x. So whatever is in front is going to be part of my answer. But once I bring that exponent down in front, what do I do with that remaining exponent up there? Yep. So 4 minus 1 is 3. So my derivative is simply 12x cubed. Okay. So Power rule is easy for simple expressions, but power rule can get a little messy if there is more, if there's more things surrounding it. But this is basically the rule. Okay. So today we're just going to practice with power rule. Now, some of the more complicated expressions have things that get in the way. So we want to make sure that that our conditions are that everything is lined up nicely before we do power rule. Because if we do power rule when things are not quite set, then our answer, our derivative won't be correct. So here are three main things that we want to make sure that we have in place before we do power rule. Make sure that your radicals are converted to rational exponents. So for example, square root of x to the fifth needs to be written as x to the 5/2. Okay, let me just go through some more examples of this. If I have square root of x, what does square root of x need to be written out as?
1/2.
1/2, x to the 1/2. And I want you to understand where that 1 and 2 is coming from. The 1 is coming from the number to the right, and the 2 is coming from the fact that this is a square root. So the 2 is coming from there. So even though we don't put the numbers there, I just want to make sure that we know where those numbers are coming from. Right? The 1 is on the right, 2 is on the left. Yeah.
You're just subtracting from 1.
Oh, no, right now I'm not doing derivative. I just wanted us to rewrite it from radical to rational exponents. Just because we want to make sure that everything is in place before you do power rule. Okay, so these conditions mean take care of these things before you do power rule.
Oh, okay.
Okay. Let me just go through some more examples here. What if I have cube root of x to the 4th? How can I rewrite that as a rational exponent? X to the 4/3. Right. What if I had the 4th root of x? X to the 1/4. What if I had the square root of x to the 7th? 7/2. Now this one, student, this one causes issues, right? And the reason why is because sometimes I see students do this, x to the 7th, sometimes they would say, they would realize that there's a number here, but they get the order wrong and they want to say it's 1/7. Okay? That's not correct. Okay. 1/7 looks like this. 1/7 looks like, that's 1/7. Okay, but the square root of x to the 7th is not x to the 1/7. Or they would say x to the 7th is equal to x to the 2/7. And I can see why students want to do that because they never realize that's the 2 there. But I think a lot of times we want to read from left to right. So we go 2/7. So that's not correct either. So just want to put a star next to that because, you know, someone's going to make this mistake. So I just want to make sure I can hopefully minimize it. And this is going to show up on the quiz. And I see a lot of 1/7. I see a lot of 2/7 instead of 7/2. Okay, so that's just something, just setting things up. The second thing is make sure that your variable is in the numerator. If you do power rule and the variable is in the denominator, it's not going to work. Okay, the variable has to come up to the top. That means you got to, if it's x to the cube in the denominator, you got to bring it up as x to the -3 before you do power rule. And the last thing is that make sure there are no parentheses standing in the way. Make sure that everything is expanded out, cleaned up, individualized before you do power rule. Okay. I know right now it kind of feels like, you know, I'm giving you a lot, so just hang on, and then I will go through each step with you. Yes.
So can you give an example of like both conditions?
Yeah. So I'll do a problem where all three conditions are in play.
Or like no, can you do one example like where like the second condition would be in place and one where the third?
Right. So if I had 1/x to the 4th power, I can't do power rule when that x is below. I need to bring it up as x to the -4 first before I can do the power rule when I move the exponent and subtract the, so I move the exponent and subtract from the exponent. Okay, so I'm throwing a lot at you right now, so we'll just kind of go back and revisit the conditions as I go through each problem. Okay, so it says find the derivatives of the following. Y equals x to the 7th. Are there any issues here that needs to be taken care of, or is this ready to go? It's ready to go, right? No radicals. There's no denominator variable. There's no parentheses. So we can say y prime is simply the derivative of this x to the 7th. And what's my power rule going to be?
X to 6. or seven times
Seven.
x to the six.
Good, 7x to the 6. We'll bring the exponent down. And then we're going to change that exponent once that number comes down. So this, whatever this curve looks like, this will just tell us the steepness of every point on that curve if I just give it an x value. And as I show this, I'm going to show you all the different variations of notations for derivatives. So y can become y prime, g will become g prime, f will become f prime. Okay. So part B, are there any cleanup methods that we need to take care of here?
First condition.
Yeah, we need to convert that radical, right? It's hard to see the exponent when it's in radical form. So I'm just going to still call this g of x because I haven't done anything calculus wise. I just want to rewrite it in a more in an easier form here. Now, cube root of x it can be written as what? X to the what?
1/3.
1/3, right? So there's a 1 hiding to the right, and a 3. The radical goes in the denominator. Okay, so we're done with the cleanup. There's no more issues, no variable in the denominator, no parentheses. So now we can be ready for g prime. Okay, so let's go through power rule. What's first?
1/3
1/3.
x to the minus 2/3.
Good. So subtracting 1 is same thing as common denominator of 3/3. Right, so I can do -1, but sometimes it's nice to just go ahead and get those matching denominators so that you can just make sure that you are subtracting your fractions correctly. So 1/3 minus 3/3 is -2/3. So this is my derivative. Okay. Now I'm going to ask you to clean this up a little more. So the only thing I asked you for cleanup is no negative exponents. So I want you to bring the variable back down to the denominator if there is a negative exponent. So that x is sitting up in the numerator. You're going to make that x come down and share the same space as that 3. So 1/3x to the 2/3. This is perfectly fine, but sometimes students ask, oh, can I put it back in radical form? You can, but I think rational form is fine. So you can write it this way. Again, you don't have to rationalize your denominator. So either of these are fine, but I think this is a little bit quicker to get to this form. So again, this is the slope formula for whatever this curve looks like. Let me change part C slightly, just so that I can kind of kill two birds with one stone here. So if I can rewrite this, y is equal to 4/3x to the 5th. So that's my starting equation. Okay, let's go down our conditions here. Are there any issues with radicals here? No, we're good, right? Is there any issue with denominator variable?
Yes.
Yes. So there's something that needs to move, and what is it that needs to move?
X.
The x. Now, does the 3 have to move with it?
Not necessarily.
Okay, so we're not going to move the 3. Okay, the 3 is going to stay in the denominator. I see some students, they want to bring that 3 up. They make it 12x to the -5, but that 3 stays. The x is not connected to the 3 in the so closely that they can't be separated. Okay, we can separate the 3 from the x. The x is going to come up. 3 is going to stay below. So we're going to rewrite this function, no calculus yet, as 4x to the -5 over what? 3 over 3. Everybody good so far? Now, if it was 3 plus x to the 5th, that's a different story. Then we can't move that x as easily, and we have different rules down the road for that. But if you have multiplication, you can separate things easily. But if there were 2 terms added, subtracted, then those are stuck for the most part. Now, before we find the derivative, I want to talk about something here. If we can try to avoid putting a number below the variable, I think that will help you visually, where you don't. I think a lot of us do get a little stressed when we have to deal with a fractional value. So something that will make things a little bit cleaner for you is if you think of it as a number in front of the variable instead of below it. So these are the same things, but this just feels a lot cleaner because you can just always have a number in front rather than a number below. Now, if there's a variable below here, then we got to be more careful. But anytime there's a number just below, you can just push it out in front and there's no harm done. Also, this feels a lot cleaner when you go through the derivative. It just feels like a number instead of a number like fractional value below. Okay. All right. So we haven't done anything calculus yet. Now we can go through power rule because our variable's in the right place. There's no parentheses to worry about. And then also there's no radicals. Okay. So
now separate the variable from the fraction.
Because 4 times x to the negative 5 over 3 is same thing as that's the same thing as 4 over 3 times x to the negative 5 over 1. I could basically separate these any way I want to. That's the nice thing about multiplication, but I want to separate it in a way that is visually easier for us. That's why we can do that. Right. Okay, so now let's find the derivative. So y prime equals. Okay, what comes down? Negative 5. So negative 5 times 4/3. I'm going to clean this up later here. I'm just bringing that negative 5 down so I can see what's going on. Now what happens with the exponent? Subtract 1. Negative 5 minus 1 is negative 6. Okay, there's my derivative. That's technically my answer, but I do want to do some cleanup. Okay. Everybody good so far? Okay, so y prime equals. Let's do some cleanup here. What fractional coefficient can I have here? Negative 20 over 3. So negative 20 over 3 times x to the negative 6. Now, something's still out of place. I have my answer, but I just want it in a cleaner form. I don't want negative exponents. So denominator. So y prime is equal to negative 20 over 3x to the 6th. These are all variations of the correct answer, but this is just the cleaned up version that I want.
Can you give an example of the third condition?
Not yet.
Okay.
I will on the next page.
Oh.
Yeah, but let's do a few more of the first two conditions. All right, everybody good so far? Now, part D. Now you have multiple terms, okay? But you see how there are no parentheses involved here, and everything is nicely separate by a plus or minus. That means we can treat each like its own individual problem. We'll do the derivative of each term, and then in the end, we'll push them together. Okay, so it's not one big problem I got to find one rule for. These are 4 individual problems that happen to just be connected to each other. However, some terms are ready, other terms are not. So what I'm going to do is I want to rewrite everything until all my terms are ready, and then in one go, I'm just going to find the derivative of each term. But I don't want to find the derivative of one, clean up the other, because then it's really hard to go back and check your work. It's like, wait, did I find the derivative here or clean up? And it's easier if we just wait until everything is ready before we find the derivative. Now I want to make another change here. If you guys can put a 5 square root of x there. I want to show some more variations and just being able to deal with a numeric coefficient in the denominator. Okay, so let's talk about cleanup here. Any cleanup necessary for the first term? No, so I'm going to just rewrite it. That's ready to go, but I don't want to find the derivative just yet. I want to wait until every term is on the same page. Okay, is the next term ready?
No.
No. How can I rewrite it?
Minus x to the 1/5.
Good. X to the 1/5. All right. There are 2 issues with this third term. What are they?
The radical is the denominator.
Denominator. Radical and denominator. So if I do the radical part first, square root of x is the same thing as x to the what?
1/2.
Okay. And then I need to move it to the top. So what does that become?
X is the second.
Well, if I'm just going to change the sign. Don't flip the exponent, just change the sign. So the 1/2, so the 1/2 becomes a what? A negative 1/2. And the 5 stays below. Good. 5 stays below. And I'm going to push it out in front. So I'm doing a couple of things all at once. If you're lost, I can and show each step, but I want to see how we feel from here to here. Are we okay with this step? So I did a couple of things here. I converted the radical to a rational. I brought the x up to the top, and I didn't want that 5 below, so I had that 2/5 standing in front. It just feels a little cleaner. It looks like my other coefficients rather than a number below my variable.
Why do you want 2/5 in front?
Because I think power rule is a little bit, it just feels a little bit weird having to stare at that 5 below. And also it looks different from the other expressions, right? And I just want to make things as familiar as possible. So that's why I like to push that number out in front. Okay. Any changes with this? The last is just a constant, so I'm going to rewrite it. Okay. Now we haven't done anything calculus-wise. We've just cleaned everything up so that the derivative can flow nicely. Okay. So now we're ready for the derivative y prime. We're going to do our derivative rule 4 times. Okay. So the first term, bring down the 2/3. Keep the 8. What's my new exponent going to be? Good. I'm just going to put a -3/3 to show what I'm doing here. I'm subtracting 1 from the exponent. I'll clean this up later. What's next?
1/5. Oh,
Yep.
1/5 times x to -4/5.
Good. So subtract 1 from the exponent. -1 is the same thing as matching common denominators and saying 5/5. Right? Keep going. Next term.
-1/2 times 2/5 x to -3/2.
Good. -2/2, which is -3/2. Okay, all this still requires cleanup, but I don't want to do too many things at once. So now, what about this? 0.875 is a what?
Right.
Constant.
Oh.
It's a constant. What happens to a constant? Becomes 0, right? Any constant is just a horizontal line. Any horizontal line is a slope 0, so my derivative of a constant is always going to be a 0. I don't need to put +0 here. I just want to show you what happened to that 0.875.
So what happened to
0.875 is same thing as a number, right? It's just a number. So a number is just going to be a horizontal line. So any slope of a horizontal line is always going to be what?
What was 0?
0.
So you just put 0 for it?
That's right. 0 for 0.875. It could be a 6. It could be pi. It could be e. It could be 45. Any derivative of a constant is going to be 0. Okay, so we technically have our answer. We've earned a majority of our credit right here, but the last point is just the cleanup. Okay, so what would you do with the cleanup here? Good. So the 2 and 8 can be 16. I can make that 16/3. I'm going to push that variable down to the denominator. Going to make it share the same space as that 3. So y prime is equal to 16/3x to the 1/3 minus 1/5x to the 4/5 minus. The 2's cancel out here. I'm just left with -1/5. I'll push this x down to the denominator. And I'm going to just drop the 0.
What does the 1 have to? The -1 have to do the 2/5? The cost of
All right, so this becomes -2/10, and I should reduce -2/10 to be -1/5.
And you bring the x down.
And I brought the x down. That's right. So whenever you want to make a variable swap between numerator and denominator, you're just going to change the sign from either negative to positive or negative to positive negative. Don't flip the fraction. Just change the sign. Okay, next page. Okay, f of x equals 1 over x squared. It says find f prime of 2, so it's a two-step process. We're going to find f prime of x first, and then once we find the derivative, we can insert the 2 into the derivative to find the slope. So this just means find the slope using the derivative function. But one step at a time, let's find f prime. But to find f prime, something's out of place, so let's rewrite this. F of x can be rewritten as what? X to the -2. It means the same thing. It's just easier for us to apply power rule when that x is sitting up top. Okay. Now let's find f prime. What's my derivative? Yeah, -2x to the -3. So there's my slope formula. I'm going to clean this up. Okay. How can I rewrite this with the positive exponent? Good. So the -2 doesn't move, just the x moves. X comes down to the bottom. So this is my first step. I found my slope formula. And now this is asking, what is the slope of this graph at exactly 2? So how can I find f prime of 2? Plug into the derivative. Yeah. So derivative will give you the slope. The original function will give you the location. It's asking just for the slope. So what's the slope at 2 for whatever the graph looks like? -140. So whatever the curve looks like at that point, it's going to have a slightly negative gradual slope of -140.
Oh, so both of those are part of your answer? So,
Well, f prime is the first part. I need to get to my derivative function before I get to my slope. So I'm just splitting up into part A and part B, but really the answer is part B, but we can't get to part B until we get to part A. Okay, example 3. Given the function, write the tangent line equation for the function at x equals 1. So here's a strategy for tangent line equation. We're going to gather our ordered pair, find the point, find the slope, and then finally we can put it into point slope form. So anytime you do tangent line equation, there's always find the point, find the slope, and then put in the point slope form. All right. So why don't we find the point first? How can I find the point? I only have the x value. How can I find the y value? Well, power rule will get to the derivative, but how can I get the ordered pair of the function?
so f equal to 1.
Well, this is the x value, right? This is not the y value. So I can just plug the 1 in for the x.
Oh, yeah.
So f of 1 is equal to the cube root of 1 squared. That's the same thing as what? Just 1. Yeah. Cube root of 1 squared is 1. Cube root of 1 is 1. So my order pair is just 1, 1. So at least I have that out of the way. Now to find the slope, I need to find the derivative. And then so similar process as example 2, I got to build the derivative first before I can find the slope value.
What is you 1 2 thirds, like 1 to 9?
Yeah, you're right. It is 1 to the 2/3, but 1 raised to anything is still going to be 1.
Oh,
Okay. How can I get this ready for my derivative process?
you got
I can rewrite the function as what?
x to the 2 thirds.
X to the 2/3. Okay, so now everything is nicely set. I can find my derivative function. Okay, so f prime equals
2 thirds times x minus 1/3.
yeah. So I've gotten my slope formula. Let me do some cleanup. Now that I have my slope formula and it's cleaned up, how can I find the slope? Plug 1 in, right? So look at how important both functions are. The 1 the f of x will give us the location for the point, and the derivative will give us the slope. They're both different pieces of information, but they're both talking about the same graph, right? Okay, so f prime of 1 is just 2 over 3 times 1 to the 1/3. What does that reduce to be? Just 2/3, right? That 1 is just going to be 1, so 2/3. So there's my slope. My slope is 2/3. So I just inserted 1 into the derivative. So 2 over 3 times 1 to the 1/3.
How do you?
Oh, 1 raised to any power is always just going to be 1. 1 to the 4th is 1. 1 to the 8th is still 1. Yeah. Okay, so we have our ordered pair, we have our slope, and now we can put into point slope form. So there's my tangent line equation.
Your answer would be to point slope form.
That's right. Answer is in point slope form. You could put it in the slope intercept form, but I'm really gonna ask that we leave it in point slope form. It's the faster one to get to and doesn't look as clean, but AP College Board accepts it, so might as well leave it in the form. That's the easiest one to get to.
That's for power. However, you don't have to show the step of like multiplying it and like finding the exponent. It's like
Oh, you mean like
2/3 times x.
No, that's fine. Yeah, you can, but I'm just going to jump from here to here. I find that once we get comfortable enough, we can just do it all in one step. Okay. All right, example 4 again. I want to make some changes, make it a little bit more involved. So if you can put a 2 in front of the root x. Now, this is messy, but we can still do power rule with this because we can actually separate them into individual fractions, split into 3 smaller problems, and then clean each of them up and then do power rule 3 times. Okay, so I want to show you how we can do that. Okay, so first things first, I'm just going to split into 3 individual fractions, and then I can kind of work on them individually. So x to the 4th over. Now I'm going to clean this up along the way here. I can write 2 root x as what? 2 x to the 1/2. And then cube root of x is what? X to the
+1/3.
Okay.
Oh, so you separate them?
Separated them. Yes, we can always do that if there's only 1 term in the denominator. Now, if there's more than 1 term in the bottom, if it was 2 root x plus 1, then we're stuck. We got to go through a different method. But for now, I want to make sure that we can see that this is not 1 problem. This is 3 smaller problems. We haven't gotten it all the way cleaned up, but this is the first step. Everybody good so far?
So what happens if there's a +1 at the bottom?
Then we got to explore a different rule. That's something for later units. We're not going to see that right now. Right. All right, so let's clean things up here. What all these x's need to be where? In the top. So when they come up, it comes x to the what? -1/2. Now, what's 4 minus 1/2? Yeah, it's 8 over 2 minus 1 over 2, right? 8 over 2 minus 1/2, 8/6. So f of x is equal to, now there's a hidden, what number do you see in front of x here? It's a 1, so there's a fractional value of 1/2. So I'm doing a couple of things at once here. I want to make sure I don't lose anybody. So I brought the x up to the top. It becomes 4 times x to the -1/2. So 4 minus 1/2 is 8 over 2 minus 1 over 2. That's why I got that 7 over 2. And I don't want to stare at a number below my variable, so I'm going to push that as a fractional value in front. Everybody okay from here to here? Okay, all right, minus, I'm going to push my coefficient out in front. I'm going to bring my variable up to the top, which becomes -1/2. So it becomes 2 minus 1/2. What's 2 minus 1/2?
3/2.
Yep, 4 over 2 minus 1 over 2 is 3 over 2. Plus 4 over 2 is just the coefficient of 2. I gotta do 1/3 minus 1/2. I need to do common denominators here. So 1/3 minus 1/2 is same thing as,
2/6 minus 3/6.
that's right, 2/6 minus 3/6, which is
Minus 1/6.
negative 1/6.
That means you could fraction, put it like fraction for it, right? This is a negative exponent.
Later, yeah. Right now it's okay because everything is up in the numerator. Yes. Because I did 1/3 minus 1/2. So 1/3 minus 1/2, I need to do common denominators. So my common denominator is 6. So I got to balance that fraction. 3 times 2 is 6. So 1 times 2 is 2. 2 times 3 is 6. 1 times 3 is 3.
I'll go calculate.
No calculator. Yeah. Yeah. And also these types of problems we need to be able to do without a calculator on the AP exam. For instance, 2/3 of your AP exam is going to be without a calculator. So we're doing all the non-calculator stuff first, and we'll bring the calculator later. Now, some students, they want to just stop here because they did so much work already, but we haven't done anything calculus yet. Okay, we've just cleaned it up so that the calculus can make sense. Everybody good so far here? Okay, so now f prime equals. Right, we bring those 7/2 down and we subtract 1 from the exponent. Bring the 3/2 down, subtract 1 from the exponent. Bring the negative 1/6 down, subtract 1 from the exponent.
7/4.
Yeah, I am just speeding up here. So the 7/2 comes down. 7/2 minus 2/2 is 5/2. Bring the 3/2 down. 3/2 minus 2/2 is 1/2. Bring the negative 1/6 down. Negative 1/6 minus 6/6 is negative 7/6. So this is technically our answer, but I want us to clean up our negative exponents. So there's a negative exponent, which we don't have here or here. It's only this one we need to move. We need to push that x down to the denominator.
What do you get? 9/4.
I did 3 times 3, which is 9, and 2 times 2, which is 4. This is almost just about as far as a power rule problem can get. So if you can do this, that's really good. But we'll get more practice with this. Okay, final example here. Connor, this answers your question of doing a problem where you got to do that third condition. So third condition is that we can only find the derivative if our parentheses are out of the way. So that 3x times x plus 1 squared is not in the proper form for us to find the derivative with power rule because there are too many things going on. So what we're going to do is we're going to expand everything out. We're going to FOIL everything out. Okay, expand first. So what does the expanded version of this look like?
3 plus 2. Plus 1x.
Yeah.
Okay.
So I'm going to clean this up first. So I get 3x times x squared plus 2x plus 1. Right, distribute that 3x through. And once that 3x distributes through, then we're good. Then once all your parentheses are out of the way, then you can treat each like an individual problem with nothing connected. So it becomes 3x cubed plus 6x squared plus 3x. And then our derivative is just 9x squared plus 12x plus 3. Now 3x, the reason why 3x becomes 3 is because just like y was mx plus b, right? If I gave you y is equal to 3x, the derivative is just going to be equal to 3. But power rule also works because 3x is really 3x to the first power, right? If I went through power rule, 1 times 3 is what? 3. And then 1 minus 1 is what? 0. Anything to the 0 power is 1, not 0, just 1. So that's why we get 1 times 3 times 1, which is 3. Okay, we did a lot today. You guys have homework. Make sure you share your homework on a separate sheet. I will do a help session tomorrow morning just to kind of go over the homework. And this is such an important topic. If you need any more support with this type of problem, I'll be here tomorrow morning, 7:30, to go over some problems. But I will send you a text from my phone.
Wait, we're over to the new tomorrow, right?
We are going to the meeting tomorrow. Yeah. Okay, go get your phones.
Yes, we have.
Oh, okay, okay.
So we'll say that.
You're right, yeah. I think you took the test 7, that's why he came in off the 309.
I did not do good on that second part, which I think you do. Oh, no. I did not.